Hello students, you are welcome to Prepclass Tutors. I am Mr. Chima, your chemistry tutor for today. So today we are going to be solving WAEC questions on chemistry for the year 2020. But before I proceed, first and foremost, you have to try to like us on our YouTube channel and like all our videos because we are going to be posting fantastic educational and very much engaging videos for you guys to enjoy. So here, I'll be treating you chemistry and we'll be looking at solved past questions focusing on what? Why? So let us start. Here we have the first question, number one, and it says, which of the following substances is an example of a fine chemical? Fine chemical. And I'm sure that we are very much familiar with all these chemical substances listed here. We are very much familiar with sodium hydroxide, it's a common base. We are familiar with hydrochloric acid, it's one of the most useful acid in the laboratory for performing what? Experiments or practicals in chemistry like titration. We are also familiar with ammonia, NH3, ammonia. I don't think we are too familiar with ethylene, but first and foremost, what is a fine chemical? A fine chemical or fine chemicals are chemicals produced in the industry in very small amounts for a specific purpose. Chemicals that are produced in industry in very small amount for a specific purpose. You must have seen that in the last slide, or in the previous slide, we have here sodium hydroxide, hydrochloric acid, ethylene, and ammonia. So I said that all the other chemicals are always seen in our chemistry laboratory in schools in large bottles, with the exception of ethylene. So out of all the chemicals listed, only ethylene is not commonly found or seen in our laboratory. So ethylene is the answer. Sodium hydroxide is produced in large quantities, hydrochloric acid in large quantities, ammonia is usually produced in large quantities in industries, and that's why we commonly see them in our laboratory because they are very, very important. So among all of them, the one that is not a fine chemical, or the one that is a fine chemical rather, sorry for that, the one that is a fine chemical is what? Ethylene. So ethylene is your best choice. Question number 2. The IUPAC name of the compound represented by the structure below is, the IUPAC name represented by the structure below is A, we say 2-chloro-but 1,3-ene, that's the option A. Option B says but 1,3-chlorodiene. Option C says 2-chloro-but-diene, and option D says 3-chloro-but-1-diene. Which one would be the answer? Before we consider looking at writing our answer, we must apply the principle for naming. And in the principle of naming hydrocarbons, we use the numbering system. You number in such a way that this double bond, because it is the functional group of this hydrocarbon, this double bond you see here, we have the smallest possible number. And also this attachment, this chlorine attaching to this carbon here, will also have a small number. So those are the rules for numbering. Now, look at the way I numbered. I numbered from behind. Now, numbering from behind, 1, 2, 3, 4. You see that you've given this carbon that is close to this double bond a small number of 1. And this third carbon, a small number of 3. Now, if I had numbered from front, I'll still have 1, 2, 3, 4. Which simply means I'll still have 1, 2, 3, which simply means the double bond will still be in the first carbon atom and the third carbon atom, which is 1,3-diene. But this chlorine here will be 3, will be in the third carbon atom. So I decided to number behind to give both the chlorine and this double bond the smallest possible number. So numbering from behind, I have 1, 2, 3, 4. So the parent name becomes what? What will be the parent name? The parent name becomes but 1,3-diene. Because 1, 2, 3, 4 represents what? Butane. butane, 4 carbon atoms. So the ene represent the double bond, the unsaturated form, the double bond. Now, because it is it is 2 double bonds that are there. One is in the first carbon atom, the other one is in the third carbon atom. That becomes diene. I hope you understand what I'm saying. 2 double bonds, one in the first carbon atom, one in the third carbon atom, diene. And because they are in the first and the third carbon atom, it is 1, 3. So that is how I got the parent name as but. Sorry for that, but 1, 3 diene. But 1, 3 diene. So you have to detect the parent name first, which is what I've just done. But 1, 3 diene. Then the attachee is chlorine, and the chlorine is in the second carbon atom, giving it 2 chloro. So writing the attachment first before the parent name, you have the name of the compound as 2 chloro but 1, 3 diene. 2 chloro but 1, 3 diene. I believe you understand how I got the name of that compound, and the option and correct answer is what? A. 2 chloro but 1, 3 diene. Very simple. Very simple. Some of you might be finding this a bit complicated, but don't worry. In our subsequent videos, we'll be handling organic chemistry, and I'll be treating you specifically on how to name these carbon compounds. They are very simple. It's no big deal. It's no big deal. So let's look at question number 3. Which of the following substance is a polypeptide? Which of the following substance is a polypeptide? We have option A, starch, option B, glycogen, option C, protein, option D, fats. You must know that polypeptide is how will I call it? Is a monomer of protein. Digestive enzymes usually break down protein, like in our digestive system. If you eat something like egg now, in your stomach, there is an enzyme in the stomach known as pepsin. Pepsin will break down that protein in the egg and convert it to what? Polypeptide. So polypeptide is a subsequent particle of what? Protein. So the correct answer is what? Protein. So the substance that has which of the following substance is a polypeptide is a protein. It's a protein. Protein is the correct answer. Question number 4. I believe you find this class engaging. Which of the following products could be formed during incomplete combustion of a hydrocarbon? Which of the following products could be formed during incomplete combustion of a hydrocarbon? Number 1, carbon. Number 2, hydrogen. Or number 3, carbon 2 oxide. You can see that they gave you 2 of them, 1 or 2. That which of them will be the product. Now, what do we mean by combustion? Combustion simply means burning. Just like when you use your stove to cook, the kerosene is a hydrocarbon. So as the kerosene is burning through the wick, that is combustion. When you use your gas to cook, as you light that gas, because that gas we use in cooking is also a hydrocarbon. As you use it to cook, it's burning. As it's burning, that process is known as what? Combustion. That process is known as what? Combustion. So when they ask you which of the following products will be a product of incomplete combustion of a hydrocarbon, it's very simple. Now, you must know that complete combustion, you can see how I answer the question here, that incomplete combustion will result in the formation of CO, that is carbon 2 oxide, steam and water, and some deposit of carbon. But normally, complete combustion usually results in the production of steam and carbon 4 oxide. So complete combustion of a hydrocarbon will usually give you steam and carbon 4 oxide, telling you that the carbon in the hydrocarbon has been completely converted to carbon 4 oxide, and the hydrogen in the hydrocarbon has been burnt and converted to steam. Steam is just like the gaseous state of water. As you are boiling your water in the kettle, the smoke coming out from the mouth of the kettle is steam. That's the gaseous state of water. water. So when hydrocarbon burns completely, it gives rise to steam and carbon dioxide. But when a hydrocarbon does not burn completely, there will be traces of carbon, because the carbon in the carbon dioxide did not completely react, and also because it was not burnt in plentiful supply of oxygen. There will be the production of what? Carbon dioxide. So the best choice there is carbon and carbon dioxide. Carbon and carbon dioxide will be the product formed when a hydrocarbon is not completely combusted or burnt. So these are answer 1 and 3, which is what? Carbon and of course carbon dioxide. Very simple. Question number 5. What quantity of electron is lost when 1 mole of iron 2 ions is oxidized to iron 3 ions? What quantity of electrons is lost when 1 mole of iron 2 ions is oxidized to iron 3 ions? Very simple. The first thing you need to do is to just form the reaction, the redox reaction. Of course, you should know that this is an oxidation reaction. Oxidation simply means a loss of electron and an increase in oxidation number. So this is the iron 2 ion. It will be oxidized to what? Iron 3 ion by losing an electron. So because it lost an electron, basically the electron will be donated to a non-metal or an anion. So its oxidation number will increase from +2 to +3. So because it lost 1 electron, it simply means it lost 1 mole of electron. So this E here, 1 electron represents 1 mole of electron. Very simple. So the correct answer is what? 1 mole of electron. So we are going to end that lesson for today. So you can always join us on WhatsApp to have more of our videos, and maybe you specifically want to request for a private tutor for you. You can engage us on WhatsApp and we are going to give you that. But all in all, always try to get in touch with us by joining us on WhatsApp and subscribing for our YouTube channel for more fantastic videos. So till we meet again, I still remain Mr. Chima, your prep class tutor on chemistry. Bye and stay safe.